Hello and welcome at my Educator Live. Today we are discussing very important topic and the first topic from engineering graphics, which is area construction. Before moving ahead, I'm assuming you're already familiar with tools like drafter, protractor, compass and roller ruler. As well, I'm also assuming you understand the concept of drawing with the different thickness of lines like main drawing lines, projection lines, guidelines. Even if you are not familiar, I will still ask you to proceed with the video and you can comment me about that and I can make the separate video for how to make different lines for the better understanding of drawing. Let's just dive in for the first topic, which is area construction. Let's just move ahead with the question, and with that we will get better understanding about area construction topic. We have our first question, which says draw a quadrilateral with sides are given AD, DC, AB and BC with one angle is also given. And after the second part of question says construct the triangle with the equal area as that of quadrilateral, and mainly if point if we have to note something here, this word which says graphically. So this is important. You cannot just calculate the area with the formulas and then transfer it in the triangle by calculating again with the formula. So one of the important concept about drawing is to first draw the rough diagram. Drawing a rough diagram is very important because rough diagram actually sets the idea what you're going to draw in actually drawing. So even for this question we'll go with the same process. So we have all the information given here, so we will draw our rough diagram. Consider any arbitrary point A, and from A you have to make one line. Don't worry about the dimensions, it's just rough diagram. So consider anything 80 mm. So consider this is A, this point, and from here this is B. Okay, now as angle A is given around 60 degrees, it will look something like that. Then we have AD and C will be here somewhere in this region. So D is AD is like 50 mm. So this point will be D. Then C point is TC 50 mm away from D. We are gonna use compass for this, and from B the C point is 60 mm away. So we will use compass for this, and this will look something like that, and then we straight have to connect that. Sorry for that. We'll do it again. So this is how our quadrilateral will look like, which will be 50 mm here and 60 mm here. On the next slide I actually have this drawing done, so let me go ahead with that. So here we have our actual drawing. This is how it looks like in real when we use all our tools to draw this. This is all our dimensions like AB 80 mm, AD and DC 50 mm and BC 60 mm. At the same time angle A will be 60 degrees. Now we will proceed to transfer the area of this quadrilateral to transfer it into the equal area of the triangle. So for that I would like to proceed with connecting hypotenuse of this quadrilateral. So we have two hypotenuse here. So hypotenuse A and C. What are the hypotenuse? Hypotenuse are just the lines with which we connect the opposite vertices. Okay, so we have this is the one of the hypotenuse. This is so AC is one of the hypotenuse and DB is one of the hypotenuse. But just by looking at it, we can see the AC is the longest hypotenuse. So this is the hypotenuse of interest, which will AC. Why? Because it is the longest. So I will ask you to just set your drafter parallel to the hypotenuse AC, and then you have to shift it to the point D, and from point D you have to draw one line which is parallel to AC. So these lines will be the guidelines. So these are the guidelines for our triangle. We checked our longest hypotenuse, and then we draw one line parallel from D, extending somewhere in the space on the top to the AC. Now I will just change the color so you can actually see the actual triangle. So where will be the vertex, like the top vertex of the triangle? For that, first what you have to do, you have to set your drafter parallel to the line BC. Okay, and from BC you have to extend this line. Which line? BC line. You are gonna extend it till this line which we draw in somewhere in the space. So this is the point of interest, and this point we'll just name it O. Once we find this point, what we are going to do, we will draw a line straight on the A, and then we have to connect from A to B. So can you see this triangle? This is our triangle of interest. So this triangle contains equal area of that of this quadrilateral. So this is called the graphical method. For better understanding, let me explain you once again with actual drawing. So here, as we did before, we draw our point of interest was A and C because that's the longest hypotenuse. If you can't find the longest hypotenuse, I will suggest use drafter to measure it. Which one is the longest? That's your point of interest. Then you will set your drafter parallel to AC, and you will draw the line somewhere in the space which is the line which goes through the D. Then you have to extend the line from BC where it will intercept this line, and that intersection point will be O, and then this from O it will go straight to the A, and it will create one triangle, and that triangle, the triangle in the red, is our triangle of interest. The blue lines are the guidelines. Guidelines, you should draw it as a feint, and usually they draw this quadrilateral and this triangle, they usually are drawn overlapping, so you don't have to draw it separately. I hope you understand. We have more questions to attempt in this area construction, so be with me. So let's just attempt one more question, same pattern, just different angles are given for better understanding. So again, the BC and CD are 70 mm which are given, AB is 50 mm, AD is 40 mm, and angle ABC is 115 degrees which is given. Transform this quadrilateral to the triangle with the equal area, and again very important, graphically. So we'll start with drawing rough diagram. So the angle B is given, so let's just draw horizontally AB first. So AB will be some 50 mm, we can use our protractor to draw 115 angle, just arbitrarily 115, something like that, from B, which is angle AB, and C. So BC is around 70 mm here, like here to there, 70 mm. You should actually write it in center. It's okay. It's just a diagram. Then from AD is 40 mm. So from A, you can use compass to make some arc like that at 40 mm, and from C to D, you can use arc something like that at 70 mm. Then you have to connect it. So this is how actually your quadrilateral will look like. Not exactly, this is just arbitrary drawing. AD, this will be D, this is 40, this will be 70. Okay, so with this I will proceed to the actual drawing. So here we got our actual drawing with all the dimensions, as AB is 50, BC is 70, and angle between them 150. AD is 40 and DC is 70 mm. So again we'll do the same way. First thing, we are gonna see the our hypotenuse. So again we have two hypotenuse. So let's just draw this AC just somehow like this. And this will be the other hypotenuse. Out of these two hypotenuse, just by looking, you can say AC is the longest hypotenuse, right? So you have to set your drafter align with AC and then shift your drafter to point D, and from D you have to draw one parallel line which goes somewhere in the space for now. Then the second thing what you're gonna do is you're gonna draw a line with placing your drafter with BC, or you can even use scale for that, and extend it till it intersects this line, and this point will be O somewhere in the space. So actual triangle we can draw from point O, which will goes down here with this line to B. Then AB will be the base of that triangle, and the third side of the triangle will be A and O. So we have to connect this with a straight line. Don't, this is just I am using the rough lines, and our area of interest of triangle will be this. Okay, so let me show you again the actual drawing. So in this drawing, as I mentioned before, A and C was the longest hypotenuse, so I made one draw one guideline through AC, and with the drafter I transfer that line, or I draw the new line parallel to the same line AC, which is from D, and then we have to extend BC till it intercepts the extent of the line from D, and then this one, this one, this is the 1, this is the 2, and this is the third side of the triangle, which will have the area equal to the quadrilateral ABCD. So our triangle of interest is AB and O. I hope you understand the concept. There are more questions. This is just like a random triangle, but there are even the questions where you have to draw isosceles triangle, equilateral triangles. For that, some different techniques are used, and I will surely help you with that also in the more videos. Again, there are area construction problems for the pentagon, hexagon, even the octagon, and then I will even help you with merging the area of two triangles into one triangle graphically. Stay tuned. So with this, let's move ahead with the more questions in the same segment. So here is our next question, which asks for draw the rectangle with sides 60 mm and 30 mm and graphically transform it into triangle of the equal area, or graphically transform it into the right angle triangle with equal area. So they can ask it anyway, that you have to make the right angle triangle or you just have to make the regular triangle. The thing which is very important here to be noted, like when you're gonna make a rectangle transform into a triangle, the answer will be right angle triangle only. So let me show it how to do it. So as we did before, we are just gonna start with the rough diagram. So let's just consider this is any random point and we'll just draw one line something 60 mm. Let's just give it a name again, A, B, and from here this might be 30 mm, around that. This angle should be 90 degrees as it says rectangle, and this will be the C. This will again 90 degrees, 30 mm. So it will look something like this. All the angles in between will be 90 degrees. Okay, so this is A, B, C, and this will be D. So before showing you actual answer, let me just make my rough drawing of the answer here. So here you can see, because all this will be like 90 degrees, the hypotenuse of both AC and BD will be the equal in the length. So here we can use either AC or either BD. But just for the clarification, I'll just show you how we are gonna do it like we did it before. We are just gonna connect hypotenuse A to C in a straight line. Always use drafter. Set your drafter parallel to line AC. Make line parallel somewhere in the space in this direction, in the top direction from D, and then you have to connect this BC line till here. This point will be O point, and then from this point you have to connect towards the A. Let me show it to you. So from point A, it straight goes to O, and from O to B, and then this is actually a triangle of interest. So here again we are on the same slide. So this is our rectangle as we draw before, which was, so this all angles will be 90 degrees, and the side is 60 mm, 30 mm. So you have to actually draw on the same drawing. You don't need to draw the separate drawing for the same. And here the blue lines will show your guidelines, which will show like connection between A and D. You have to set the drafter parallel to AC, and then move that line towards D point, and from there make the one line which is parallel to the same AC line, extend it, and then you have to like extend this BC line till it meets this extent of D. The intersection will happen at O. So from O you drop a line which is on A, So A, B and O will be your triangle of interest as we mentioned before. And as per the question, they have told us like this angle is already we know is right angle. So this is right angle triangle, and as well this is the equal area triangle compared to this rectangle. Let's move ahead with one more question and see what it brings us. So draw square with 60 mm side and graphically transform it into isosceles triangle of equal area. So here the important things which we need to understand graphically, and here they are asking us for isosceles triangle. So it's not like we can just make any kind of triangle. We need to draw it, we need to transform it into isosceles triangle only. Okay, so those are the important things we have to remember in this case, which is considerably very easy, not tough. One more thing I will recommend here while drawing such type of like graphical transformation, you always should use drafter just makes your work faster and easier, and at the same time it gives you advantage of being accurate. So a square of 60 mm is as shown here. So this is 60 mm. You have to draw line AB. I am not going with the rough drawing this time. So A to B 60, B to C 60. This angle will be 90. Drafter will be very useful to draw this. And then again, this is again 60 mm, and D to C again 60 mm. So very important thing we can do it with the drafter is while drawing isosceles triangle. Let me make the, you have to bisect this AB line. So somewhere here, so it's like 30 mm, and it's this part is 30 mm, and same with this point also, and then just connect it straight. You just have to connect it. So can you tell me what is the length of this line? It will be 60 mm. So one more thing you have to do, you have to extend this line on the top. It will go straight from, let's just give it a name, something X, Y and O. So this will be 60 mm, and till O it will be 60 mm again. So you have to extend this line, so it will make something like 60 mm inside the square, 60 mm above the square. What you're gonna do after that, you have to straight connect from point A to O, and then drop this. It should be a straight line, sorry for that. So but you understand the concept, you have to draw a straight line from O to B and from O to A. And in next slide actually I will show you how it works. So here we are on this slide. So this is our square ABCD, and I have actually given name M and N here, and this point is O. So here as I said, you have to bisect this line. You don't have to use compass really, you can use even drafter. Just set it at the like 30 mm somewhere, and then make a line which is like twice the length of this. So 60 60, so this will be 120 mm, because you want half of it inside the square and half on the top extent. And after O point, you have to straight drop the point, drop the line from O to A and O to B. This will make the equal angle, and so it will become isosceles triangle. So this is how you draw the isosceles triangle from the square for the equal area transformation using graphical method. Let's go ahead and see one more question. So this question says draw a parallelogram with side 70 mm, side AB and side BC is 60 mm. Angle given A is 75 degrees. Graphically transform area of parallelogram into triangle with a equal construction area and twice the height or altitude of parallelogram. So here it's saying twice the height or altitude with the equal area. So that's important. If you remember, we did the same thing when we were drawing isosceles triangle in the square question. So it will be kind of similar construction, or part of the question says use the graphical method to transform the area of parallelogram into isosceles, or they are straightforward ask you to draw isosceles triangle. So just remember, if they ask you to make the height twice here or to draw isosceles, you need to remember you have to find the base of the drawing, and from there you have to draw a bisector. So let's move ahead. So parallelogram is has four sides, and opposite sides are parallel to each other and equal in the length, and and the supplementary angle total should be 180 degrees. That means if this is 75, this should be 105. So this is the rule of parallelogram. So let's just start with actually drawing parallelogram. So it is angle A, B, C, D. So it will look somewhat like this. And I think the question says this is 70 mm and this is 60 mm. So we'll start with AB, make it 70 mm, then make 105 degrees, or you can even make AD as 60 mm. Use your drafter or compass to find this point at 70 mm, and this will be 60 mm from here. You can use the drafters. You have to set it at 105 to make this line. So just as simple as that. Let's move ahead on the next slide. So what is the height of the parallelogram? Can we guess that? So from here to here, this distance with a straight perpendicular line. But for this question, we don't actually have to go for that. As I told you before, just go with the drafter, bisect this point 70, so somewhere around 35 mm on this side, 35 mm on this side, and then just draw a line which goes straight, which will bisect here. You can use drafter to make the twice of extent of this line, or use your compass, like just draw somewhere this line like this, and then use your compass to take this distance and arc wherever, like it will be, I think this will be somewhere here, so make this as O. Consider it, this is M, N and O. After that, as we did before, you have to straight connect O to A and to B. So this will become like twice the height. At the same time, it will make it into isosceles triangle. Simple as that. I don't think there is anything which you don't understand. To start this, I will tell you again. You have to set your drafter parallel to AB, and with your vertical edge, just draw a line. This line MN, you can extend it, and then you can either use drafter to find this point which is of equal length of MN. So MN is equal to NO, or you can use compass to make an arc and find this point. And after that, you have to straight connect ANO and BNO. Let's go on next slide where actually I have created this drawing for you. So here it is. What you have to do, find this point M, extend it, see it's of the equal length, so that becomes twice the length. And after that, straight connect O to A and O to B, and your area of interest will be this triangle AB. So this is for the part 1 of the video where we did like how to transfer the quadrilateral areas into triangle. And after this, what we'll do is, in the next part we will do how to merge the area of two triangles like this. They will give you two triangles and they merge it into the one single triangle graphically again. Then we will transfer area of hexagon and triangle into one triangle, then pentagon and triangle. So all this is coming up, so stay tuned.